So we're going to talk about Hibernate, you know it, but you don't. And so what I hope is that with a library which probably everybody has been needing to use with one project or another, we can still surprise you or teach you something new because the project is far from dead. We have an immense amount of downloads every month, very strong interest. And the team is actively working all the time to fix bugs that you're reporting, improve everything that we can think to improve, and adding new features. Now the problem is that there is so much about Hibernate out there, and there are so many blogs and new posts that it becomes a bit hard for us to know what you think we are doing, and I suspect also for you to actually know what's new in Hibernate. So that's what we are here about. So I'm here replacing Emmanuel Bernard, who's my teammate, friend, and a colleague. He couldn't come, so I'm replacing him. But we work on the same team. We have been working on the same team for a long time, so we can go on. So what do I hope you take away from this is, well, I'm going to give you like a general overview of all the Hibernate projects and what's new, so that probably if you already used it in the past and you were stuck on an older version, this might come with some new features and some new ideas for your projects to come home. Now, in particular, how do you get news about Hibernate? So I was looking around myself recently, and I figured out, so this is something I searched on Twitter yesterday, and it's like, oh wow, Android? I didn't know. Well, of course it doesn't, but Hibernate is there all the time on Twitter. Somebody's mentioning it. I measure it more than once every minute. So how can you find when we are publishing something new about it? And the thread goes on. We have JavaScript. Oh, okay, that's totally new. And then there is people recommending it for beginners, apparently. You're learning to program. You're supposed to know Hibernate. Well, that doesn't sound entirely right now. But it even goes beyond, social media. You are learning how to do marketing on Facebook, or you have to learn about Hibernate first. Well, that's flattering, but I'm afraid that's not really necessary. Now, about social media, I'm probably doing it wrong here. I'm not really finding any of the information that I'm looking for myself in the community. And, so who I am. I've been using Hibernate for a long time now. I've been contributing to it in the past 10 years. Initially on my own time, then working for a consulting company, and since 7 years today, this is actually my employment anniversary, I'm working for Red Hat full-time on all the libraries from every workday, some weekdays, some evenings, trying to figure out how to improve something on it, and I have lots of fun with it. So let's see, what do we have recently? Well, first off, it's no longer just the ORM. We have now a full portfolio of libraries which are strongly interconnected to try to help you with all kind of problems that you might have working in a Java world and having to interact with your data. Of course, you all know about Hibernate ORM because it's been there for a very long time. You probably know about Hibernate Search as well because it has been there for about 8 years now. Still, it feels a bit eclipsed from all the news coming out about Hibernate ORM. So it's always a bit puzzling for us. How do I get the news to you? Okay, you have Hibernate Search as well now, and it's really useful. Most of the people I have been interacting is via Hibernate Search because that's the project I've been leading more for the last 7 years. And, well, we have Hibernate Validator, Hibernate OGM, Hibernate Tools, and some other experiments or help for repositories. But let's focus on Hibernate ORM 5 first. So who's been using Hibernate 5? So that's not many. Who's using older versions? Yeah, see, that's the big problem we're having. You have thousands of I wouldn't say even commits, because commits goes in the 50, 100,000 commits beyond Hibernate 4, Hibernate 3, and so on. But we definitely have at least like 6,000 JIRAs of improvements, bug fixes beyond Hibernate 4, going forward. So if you're not using Hibernate 5, you're really using older technology, which is slow, problemsome to integrate with other libraries. And I would really encourage you to upgrade. And here we're going to see some good reasons to upgrade. So one of the first things we did in Hibernate 5 is really clean up the bootstrap process. Like, it was very entangled. We need to do all kind of things from the class path point of view, like we need to interact with other libraries, other frameworks, countless of other libraries interact with Hibernate itself. And of course, we need to load your classes, probably load some configurational resources. You might have some mapping, legacy XML files, other kind of sources, annotations on your classes. So we need to discover all these things. And all these different phases and discoveries, extension points, custom converters that you might have around became very entangled over the years while developing new features on Hibernate. So we had like a full cleanup of how it's booting. And modularity had a lot to do with this. So we want Hibernate to work fine in whatever modular system you are using or planning to use. So WildFly was one of them. Is one of them. OSGI is one of them. It used to be really hard to get Hibernate working correctly in OSGI because of all the class loading, isolation, not isolations, or not really being designed up front. And of course, Java 9. We know it was coming since a long time, so I've been looking at how modules could help with the system. Now, how does the new Bootstrap look like? You start defining a service registry. And the service registry is a place where we contain all the services that Hibernate will need to run. So you can configure this with an external file. You don't have to. There is a simplified Bootstrap API for this, especially like if you're using JPA. You don't need to know anything about this, but it is really useful to know these details so that you can customize any of the internals that Hibernate actually uses. For example, you might have a different connection pool in there. You want to inject it like programmatically, so you just create it and you pass it in. Of course, having a connection pool is something that Hibernate will need very early during the Bootstrap because it needs to verify, is this the database that you told me we're going to use? Let me check that. Is it like the right version? And depending on the version, we're going to maybe change the schema or verify some things. And after the initial setup has been done, we need to validate, is your schema matching? And there's countless of nice things that need to be done, but the connection needs to be there early on. And then we need metadata about what your objects are, how they are mapped, what's the schema, and we have plenty of sources of metadata. So you can add an annotated class, you can define, you can enlist the class by full name, or you can just add, static XML file configurations again. And after you have defined a metadata, which takes, the registry, then you combine the registry and the metadata, and then you can finally get the session factory started. So this makes it much easier for all the integration points to actually know that we are starting in the right order with all the right configurations. Of course, there is Java 8 support. It comes with all these improved date and time types, which, of course, you want to use now, and so you want to map these on your database. So we're supporting these today. And, we'll see later about what the generics and autoclose come, but so about date and time. Initially, we were not requiring Java 8, so if you were using Hibernate 5.0, you needed this additional, maybe an artifact, which would contain all these extension points, which were optional. But since Hibernate ORM 5.1, you actually are required to run on Java 8. So these additional dependencies are no longer needed. It's merged in the main project. And of course, these are just some examples of the types which are now supported out of the box by the main library. Now, when it comes to autoclosable, this is very nice. So, of course, this is around since Java 7. And it's just a more convenient way to make sure that resources which need to be closed that will actually get closed when you're done with them. So you can have this try. You open the session in the try block, and it means that this will absolutely be closed. You don't need to explicitly write a final block. I have a funny story about this one. We didn't do this for a very long time until somebody on Twitter asked me, why doesn't session implement auto-closable? And we asked ourselves, well, I don't know, why doesn't it? So it was a half an hour conversation among the team, like to do how exactly do we want to do it, and 5 minutes coding, and then we had this new big nice improvement in there. And it was astonishing for us to, we have been using Java 7 for a long time before we actually did this, because we hadn't thought about it. And that was your feedback, somebody who just sent a tweet, and okay, I can do that, right? I had the IDE open, and it was very easy. And of course, so the session is auto-closable, and of course the stateless session as well. The session factory is auto-closable as well. I'm not sure if you're needing it. And the scrollable results also, they need to be closed. So now they're auto-closable, which has a nice side effect of you getting a big fat warning in the IDEs when you're actually not forgetting to close these things. And that prevents some more bugs. Now, in Hibernate 5.2, we did this additional improvement that the session actually implements Entity Manager directly. So you don't have to deal with two different objects to deal, like what are you using? Hibernate Native API sessions, or do you prefer Entity Managers? That used to be two different things. And we had Entity Managers was essentially like an adapter on top of our session to implement the standard API. That's no longer the case. Now we moved all the methods which provide just features which are specified in the JPA spec. They just implement the spec directly. So the JPA interface is no longer optional. You have to use it. You can still code against org Hibernate session if you prefer this API, but this will also implement the Entity Manager, so you can just assign it if you need so. This isn't just a convenience, actually. We have been working a lot on performance, and having an adapter to wrap around a session really felt like we're wasting your memory. Why do you need to have an additional object just to wrap something which then wraps the internal services? And so we got rid of that, and we'll see some more of these improvements have done, of course, this single improvement wasn't going to make a big change for you, but we have been working a lot on performance, and the combination of all these differences actually made a very big improvement in terms of application performance. So we improved the bytecode instrumentation a lot. Now, especially if you have been using these very old versions of Hibernate, you might have seen that your entities are not really your entity classes. So there is a proxy based on cglib or some other libraries like that. It's much smarter now. I will doubt, actually, that in practice you will ever see the difference. So you will never, ever again have bugs like that your class isn't really the class it's meant to, or it's declaring to be, because you will always ever have a single class definition, which is your entity. And we are not creating additional copies of this because we actually modify the one and only class definition. This prevents a lot of really complex situations and just makes your life a lot easier. Now, why do we do bytecode instrumentation? The best part is there are many nice parts actually, but another performance issue that you might have seen when you have very large complex graphs was dirty checking. So when we are loading an entity, you have a list of properties that are loaded from the database, and then you make some changes during the life cycle of your entities, and then at commit time we need to verify what did you change in which of the objects, and the objects which are detected to be changed, how are they detected to be changed. We compare all these attributes with the original copies that we loaded from the database. Now, when we can do bytecode instrumentation on your entities, we don't need to keep around a copy of the original data, and we don't need to compare property by property, because we will just inject some code in your entity which is going to turn on a flag, making sure that we know this entity was modified. And, well, there are now Maven and Gradle plugins. The users will just be add end tasks to perform this. Going to soon to see an example of this. And you can do lazy loading of subgroups of your properties. So you can do just lazy loading of collections or relations of your main entity, but you can pick some of the properties of your entity and say that typically you don't want to load these properties at all, unless you are enabling the group. And then we can actually trigger the lazy load when you're reading the specific property. And bidirectional management, I remember as a junior developer, I was mad to Hibernate. Like, why isn't this automated? Why doesn't it just work out of the box? Well, it finally works out of the box. So how do we enable these features? Well, on Java EE, we have some properties that you enabled. So it's by configuration. You say you want it enabled, and then you can pick which of these features you want to be enabled. You know, in case you don't like some of these enhancements, you can opt to not enable them. Now that's very nice. It means when you're running it in a container like WildFly, you don't need to know how to enhance your entities. You just need to enable the feature, and your deployment, your war, your whatever, what you're deploying on your application server, as soon as the classes get defined, they will be modified, and the class definition is then the only correct class definition. It will have the bytecode in there that we need to perform this kind of magic. If you're not running in a container, you have these Maven plugins. So again, that's the group ID and artifact ID, and then you just say during your build of your project, you want your classes to be enhanced, and again, you can pick which of these enhancements you want to use. And there is a similar thing for Gradle. Very straightforward. Now going back again on it, lazy properties. This is an example. So you have this customer entity, and we have this accounts payable external reference ID with this basic fetch lazy. So this is a field. It's not even a getter. We're not going to load that field from the database unless you explicitly tell us to, or unless you are going to read it. Then a second SQL statement will trigger on the database, and we're going to fetch it transparently so you don't know. And of course, for a single UID, that might be overkill. But when you're loading large stuff like a blob image, it might improve. It might make a big difference on your application. Not to not load a large set of data that you're not needing. Association management. So I love this one. You have a relation. In this case, let's make an example of like the order. So an order contains multiple line items in there. And so we're creating one. That means you have to create an order. You have to create one line item. And then you have to add this line item to the line items of the order, and vice versa. You always have to remember updating both sides of the relation. Now, of course, this is just Java, right? You're not even using Hibernate yet. So you're creating two sets. You want, like a set and a relation, you want them to point one to another. You have to update both sides. It's plain Java SC, very standard, straightforward. But it is annoying when this is a relational connection. Like the framework should be able to help you with that. So when it's enhanced with bytecode instrumentation, you don't have to, because when you're invoking the get line items on add, or vice versa on the set, it will update the other side of the relation automatically for you, so that you don't have an NPA because you forget to do something simple like that. Now, speaking of bytecode enhancement, in the past we used the cglib that has been long removed. More recently we were using JavaSist. Now we also have ByteBuddy as an alternative. Raphael, who's like the ByteBuddy creator, contributed this himself, and that was really nice. And we're thinking that maybe in the future we should just drop JavaSist, which is now the current pretty much default, and just switch to ByteBuddy. The reason is there are two important reasons. One is it's based on ISM. So we've been monitoring what Java 9 was doing since a couple of years. We were on these, test early versions of Java 9 program to make sure that Hibernate would, work on the day of release. And something that has always been breaking was JavaSys, because the team of JavaSys wasn't really very proactively checking that it would work at Java 9 as well. So we were like filing issues. And they were very nice, they were fixing them. So today JavaSys works fine on Java 9, as far as I know, because I guess everything is quite new now, so it's not battle tested. But ISM is part of the OpenJDK team project, extended, let's say, or the extended OpenJDK project. So the people working on ISM are constantly making sure that ISM will work with the latest version of JDK. So it is more convenient for us to maybe rely on ISM than JavaSys going forward in the future. Now another nice property of using ISM is when you're using JavaSys, your entity, the instrumented entity, gets injected some code which has references to JavaSys helpers. That's nice, makes the JavaSys library easier to maintain, I guess. But in the world of modularity, it means that now your application, when it's deployed, it needs to be able to load JavaSys classes, while we want to clean up dependencies. Like if you haven't defined, if your application has no need for JavaSys, why should we inject this? So if you're using ByteBuddy, this dependency is only during the instrumentation phase, and then at runtime there is no dependency at all. So that's really nice, and we like that. Another new feature of Hibernate ORM is now it supports SAP HANA. And that's very impressive because it's not really a relational database, but it exposes a JDBC standard API. So you can talk to HANA. This is like an in-memory super data grid platform. It is this in-memory scalable analytics, like a very modern database by SAP. And the SAP engineers contributed many features like improvements to Hibernate, like improved spatial types to be able to exploit the HANA engine at best. And of course, they contributed the dialect so that now you can just, replace your another database with HANA and just keep using Hibernate as usual. And it was all done contributed by them. Some guidance, of course, but. Now, the second level cache improved massively. The previous version was allocating very expensive keys for every time you were needing to access the actual cache, making the lookup in a cache actually a relatively expensive operation. When you are looking at like high-scale, high-performance systems, this was not negligible. So we improved this a lot by just internal redesign using the newer tools that might not have been available 10 years ago when the second level cache integration was designed. And so the performance improvements are dramatic when you're using caching for this case. It's highly recommended. If you need to have good performance and you obviously are using second level cache in that case, then the improvements are making a very strong difference. Now, on top of this, we also support now integration with the cache provider over the JCache standard API, and this was contributed by the AHCache team. So traditionally in Hibernate we have had like mostly two second level cache integrations. One was AHCache contributed by the AHCache team, the other one is Infinispan contributed by the Infinispan team. And both of them maintain their own integration points, and that's very nice. And so that means they also have a lot of expertise on how the caching integration actually is best done. And so now you can use JCache, which means it's easier also to plug or play with alternative caching libraries. I guess you can use, Cache2K seems to be a good one. Hazelcast is another option. And, any cache which implements JCache is now compatible with Hibernate. So you can play and experiment. Now, a big feature is actually reference caching. Now, as I said before, when Hibernate is loading something from a database, it needs to keep the properties that it's loading from the it's just columns. So we're keeping this around when you need to do dirty checking and verify what's actually changed. And now these columns are exactly what we're keeping in the cache. That means that every time you're loading something which is in the cache, we will create a new entity instance for you and populate all its properties with the values that we're getting from the cache. But that means a new entity is being materialized every time you're hitting the cache. Now, in a world in which we're really trying to minimize the amount of data that's being allocated at runtime by your system, allocating this new instance is a cost that you actually might want to avoid, especially if it's reference data. So if it's data like a country, it's always having the same name. You don't need to create a new instance of France, a new instance of Belgium every time somebody has an address who lives in Belgium or in France. You can safely reuse the same instance. Now, by safely reuse, that means it has to be immutable. Absolutely. If it's not immutable, Hibernate is it's going to refuse to use the caching by reference, because if you make any change to it, it means that this change will be leaking to all the open sessions. It might be different transactions, and other transactions might see this change, which might be uncommitted. So that's that's an unsafe state, and it's also a bit illegal in terms of the Java memory concurrency. It's not really visible correctly. So it has to be immutable, and you have to enable these caching options, and you have to enable the global option, use reference entries. Now, a very big improvement has been the documentation. It's pretty much been rewritten from scratch. Like, we've thrown away everything, and everybody who has been reading the new documentation has sent us lots of thanks. Apparently it's much better. So if you haven't done yet, I would really encourage you to go to the new website. The website was also redesigned, and the new documentation is much better, much clearer. We also have a blog. It's in.relation.2. So please follow this blog, because this is where we blog about these new features when they come out. And obviously, as we have seen before, even searching on Google, searching on Twitter, you find a lot of stuff with a lot of recommendations that I would never really suggest myself. We also have that's a little memo, how do you get a session back from the entity manager? Since now we're encouraging everybody to use the entity manager, since that's the main entry point. But of course, sometimes we are creating or implementing something new which is not available yet in the specification. So to extract actually the session interface out of the entity manager, you use the unwrap method. And now this is an example of a new nice feature, set JDBC batch size. This used to be an option which was global for the session factory. So you would set what's the batch size to use for all your JDBC statements for the application. But so global, not really interesting to tune for different use cases. Now it's on the session, so you can have different use cases tuned differently. Let's switch to the next project, Hibernate Search. Whoever knew that Hibernate Search existed? Okay, well, not too bad, but still, we are not there yet. So it is about integrating full-text search in your applications. Full-text search is pervasive. All applications having to do with humans expect to have a text box in which they can type something really quickly, and you find out exactly what they mean or what they need. That means they expect you to compensate for typos, different ways of expressing things, mismatches of names and all that. And this is surprisingly difficult to tune or get right on a relational database. So we use Apache Lucene, which is great and does it in a much better, more flexible way. And it's also like a nice Java library, and open source, of course. So Hibernate Search is about helping you translate back and forth your domain design into the world of the Lucene objects, which is based on documents, Lucene, and text, essentially. So everything needs to be transformed in text, and extracting tokens of text, manipulating this text, and calculating matches around that. More recently, we also have Elasticsearch integration, and I'm going to talk a bit more about that soon. So what's new in Hibernate Search 5? Well, the biggest, let's say 5.0, the biggest news was that we are having a very strong upgrade in Lucene versions. And the nice part was we didn't change absolutely anything in terms of APIs for you. Now, it was still a major update from our point of view because we expose Lucene directly. Like, we're not hiding Lucene behind some kind of abstraction. Lucene has a very powerful, rich query language. Query API. So we want you to use that and benefit from all the new stuff that Lucene is making all the time. That means that when we are jumping up to a very significant upgrade in the Lucene version, that side of the API will be different. So your application needs to take that into account. But our API has been surprisingly stable. And that's because we don't expose any of the write methods. So you don't have to bother with writing stuff into Lucene because we do that. We listen to the changes that you have on Hibernate ORM side. So you are making changes on your database. As soon as you commit, we make sure that we make these same changes in the database and in the Lucene index. So the Lucene index is always like a representation of your database state. And then what you can do on top of this is query it, which is, of course, the interesting part. And there we expose you like full freedom. Do whatever you want with the index. We did a lot of performance improvements, and we're working on the WildFly swarm integration, Spring Boot integration. So, anywhere where you can run Hibernate, you can run Hibernate Search. Actually, to enable it, you just have to have it on the class path, and like Hibernate ORM will pick it up, and you have the additional capabilities. Let's see a quick example. This is like trying to conflate some of the features that it provides. So what you can see is this is an entity, and then on top of that we add its indexed. This is what enables all the Lucene powers, and we also use the Spatial extensions for the indexing engine. So the indexing is opt-in, so you need to pick which fields you want indexed. For example, oh, you don't see that. So this makes the field street1 to be part of your index. You don't have to include all the objects that you're storing in your database also in the index because they might not be relevant for what you expect people to search. So we're making street1 a part of the index. We're making city also part of the index. And in this case, we're making it sortable, which is another annotation, and facet. This enables faceting queries on top of the city. We'll see soon what that means. And this is, well, a numeric field which also gets indexed. The numeric field is actually optional, but you can use it to like force some behavior. And we have latitude and longitude. Well, they don't have to match the name, of course, but if you have some numeric fields which you want to have a meaning to run spatial queries on top of them, you annotate them with a latitude annotation or with a longitude annotation, and that's tied up with the spatial. And you can embed relations. Now, in Lucene world, there are no relations. It's a flat document, but it is a multi-valued flat document. So we can embed and denormalize your complex, rich data structure into Lucene index by using index embedded and contained. Not going too much into details because we have a lot of stuff. Now, and this is how a query looks like when we're using the Hibernate Search DSL helper. The first thing you need is a query builder. And a query builder is specific for the type you are going to look at. So in this case, we're going to search for addresses. So we take the query builder for the addresses. And then, so this query builder, this is Hibernate Search code. But what you can see here is it returns an org Apache Lucene query. As I said before, we expose you to the Lucene API, and we encourage you to use it directly so that you're not locked in for advanced features that we might not expose over the DSL. So the DSL helps you for the most frequently used cases, of course, but you can also like just create a Lucene query directly. Now, in this case, what we do is we create a Boolean query. So that's the starting point to say I'm going to combine 3 queries. And that's why we have this indentation here. Now the first query is a spatial query. We're going to say in kilometers that we want this place to be in a certain radius. Central latitude, central longitude, that's how you define. I want it to be close to this point in space. And this is a must. Note, these are Boolean queries, but it's almost like fuzzy logic. It's about scoring different results. Sorry. Now, we also search on the street name, and we use a fuzzy matching on the street name. That means typos are acceptable. Of course, the user who's writing the street name exactly right, and this is like a perfect match, this will score higher in the overall results. But we are also going to accept things which are close enough to it. And the close enough definition is what defines the fuzzy. And we're also going to assume that we're looking for an address which should. And this means that this is like not a mandatory filter, but we would prefer the address that we're looking for. Let's say we're looking for an apartment here, and this is my ideal apartment. I want it to be in this area. And I would prefer the floor to be above the second, because I like that better. Now, when you run a query like this, this is going through your database in the index form and going to match with all the results which are most similar. It's going to give the results ordered by score. So the stuff which matches most or is most relevant for a user is going to be on top. Like you're running a query, on the Amazon shop or on Google, what's most relevant needs to be on top. And so you can tune all the aspects of the system to define what's most relevant for your specific domain. And this is how you run a faceting query. So we said on the cities field, we allow faceting. And again, if you think about the Amazon interface, on the left, when you run a query, you have groups. And this allows you to do exactly that. I need to speed up a bit. Second part of running the faceting query. It's a bit more complex because you can define multiple groups. So you want the query, like the results, they will be organized by lists, but also in the different groups that you defined. So for example, by city or brand or the things that you're looking for. And the nice part is you don't have to define the categories of your groups in advance because it will just infer this from the data that you're having. Now, a simple query string is another new feature of Hibernate Search. Now, very often you have a single text input. You don't want to have a big form and have people fill in all the parts of the form. You want one search box and people type into something, and then you want to match this text with multiple parts of your index. So in this case, we're looking for a book. War Peace is the two keywords that someone is entering. And so we take the query builder for the books type, and then we define we're going to run a simple query. Simple query string is actually the technical name in the Lucene project for the kind of parser that you're going to use for this query. So you could have some more advanced elements into this query, and it will take that into account. But in this side, this is your code, so this is where you are going to hint the engine, like which of the fields matter of your document that should match with whatever the user is inputting. So we're going to say, I want it to match with the title field of the elements or of your documents and the summary, but the title is more important, so you're boosting that. And then you run the query. Now, the return of these queries, sorry, I didn't mention that before, but that's very interesting. So we're running these queries on the Lucene index, but the return, the list of books there, they're loaded via Hibernate in a transaction, and it's managed entities with their full, all the data that you would have by querying this data from the database. Now, Elasticsearch, it's all the same. Since we hide you how we write things, we can automatically write into Elasticsearch. You have to still provide the same kind of schema, so you're defining from your domain model which of the fields you need to be indexed. And when you make changes via the Hibernate API, this will synchronize on the database and on your Elasticsearch cluster. We're supporting all of the Elasticsearch versions from 2 to 5.6, which is the last stable version, so we're trying to keep up with whatever they release. It's just 2 lines of configuration to enable these additional capabilities. You need to tell him which indexes you want to store in Elasticsearch rather than on a basic Lucene. So that's 1 line. And then a URL which points to the Elasticsearch cluster you want to use. And let's go to the next project because time is going on. We have Hibernate OGM. This is our adventure to have you store or use any NoSQL store using the JPA API. These are the data stores that we are supporting today. MongoDB works. InfiniSpan works in remote and embedded. Neo4j works in remote and embedded. And we also have experimental support for Redis, Hcache, Cassandra, and CouchDB. Now, what works means that depends exactly on the NoSQL technology, because some of them might not provide some fundamental feature that you need. For example, MongoDB is notoriously non-transactional. That means that when Hibernate, when you are using the transaction API on the JPA or in your application server, it just means that we are not going to flush any change until you commit your business unit transaction. But if there are multiple operations that need to be written during this flush, there is no guarantee that they are going to be applied all or nothing, because MongoDB cannot do that. On the other side, InfiniSpan and Neo4j are fully transactional, so you're good with this. And for example, if you're using Neo4j, it means you can start writing things into Neo4j and use the transactions, and then you can access this via HQL queries, or you can use the Neo4j native queries as well to materialize entities back out of it. So it started as a crazy idea. It's actually matching really well with some of the NoSQL stores out there. How do you get started with OGM? Well, you need a dependency, and the dependency here, so in Hibernate ORM, you might be used that it's one dependency for any database. You just have to pick a specific dialect. With OGM, that's not the case. You need to actually pick a specific dependency depending on which database you intend to use. So in this case, we pick the Hibernate OGM Neo4j integration, which will depend on Hibernate OGM core and some other libraries that we use. And then in your persistence XML, you have to essentially change the provider to the Hibernate OGM persistence provider. In the configurations, you have to say, I'm using the Neo4j one. This is because you might have multiple extensions on that. And that's it. Then you use JPA with a normal interface. So we can move on to Hibernate Validator. What's new in the Hibernate Validator phase? Well, of course, there has been Bean Validation 2. Hibernate Validator is the reference implementation of the standard. So we are heavily involved with this. And there was a quickie today here by Gunnar, my teammate, who's also the specification lead for Bean Validation. So he has been diving a bit deeper into it. Well, it was a quickie, so not too deep. But I'll just repeat some of the key points. The most interesting part is you can now annotate arguments on methods and make sure that, so this create user is no longer going to be invoked if that user is not like a valid and a not null user. So this is a new kind of validation. And we are extensively using the Java 8 new capabilities. So that means repeatable annotations, support for the new types, and we can actually validate here, show in error messages the actual name of the parameters that you're using in your source code. And this is very sweet, I think. So here we are defining in this user as a validation constraint. We are saying that this size here, maximum 10, this is applying on the list. That means the whole list as a collection is not valid if it's larger than 10. But we're also having annotations in here, in the generic section. You see that? So that means that every single string which is added into this list needs to be not null, it needs to be a valid email. This is a new capability that we couldn't do before Java 8. And well, if you don't like to pollute your classes with the bean validation, well, the bean validation annotations, we offer now programmatic APIs so that you can set them up by configuration, essentially. Also, validation 6 is much faster. This is a comparison, like in operations per second. You can find it on our blog. This was blogged last week, so it's very recent news. We just finished doing these benchmarks. So the big blue line is the performance of the last version. And then we have the previous Hibernate validation version, and this is the Apache implementation, which hasn't been updated for a while. Hibernate Spatial. Did you know that Hibernate is able to query and integrate with spatial types in your database? So there is a difference that you need to be aware of between Hibernate Search Spatial and Hibernate Spatial. Hibernate Search Spatial uses the Lucene index, and it only works into radiuses. So you want to find an address which is close to a certain point. You want to find, a pizzeria which has a name that sounds like, something you ever heard. So fuzzy matching of text that works on a by distance base, but the Hibernate Spatial actually integrates with spatial functions in the relational database, so that can use much more advanced polygons and so it integrates with the JTS library. To have an example, here we are storing the event, and this is a helper from the JTS library in which we can read, some points, and so you store this, and then you can do an HQL query, and then you can search for things which are in some kind of complex polygon. So that's not just trigonometric distance, but in complex objects. Hibernate Inverse, there is not much to say except it was initially a very welcome community project. There has been much more traction now, so we actually have now fully staffed people working on it, so it's finally getting a much nicer improvement. And what's next? Hibernate 6 is coming. We are working very hard on this, but it's still a lot of work. The internal, we call it semantic query model. The internal way in which queries are defined is completely changed. You have now, this is going to unify the representation of queries in a way which actually has a purpose. So it's not just string being appended and being generated, but there actually is a goal. And so this is unifying like the criteria API, the HQL parser. So it's both parsing and generation. It allows us to generate much more efficient queries so that we can actually optimize the full shape of the output SQL depending on your database capabilities. There is much more coming. Yandex annotation scanning will make our bootstrap more efficient, and it also allows us to read your model without actually initializing the classes. That prevents some integration points for breaking, and we have Java 9 support and better modularity. So about Java 9, Hibernate ORM just works as long as you update, because the older versions won't work. Hibernate validation, the same story, Hibernate Search as well. But you really have to update to the latest versions. Like we only completed compatibility this summer, and we just know about issues with JavaSys and other libraries. If you're using even a version which is 1 year old, it's not going to work nicely out of the box. You might need to add some additional flags. But this is in class path mode. As modules, it's a bit more complex. In particular, there are issues with the JTA API cannot be changed into a module yet. The JPA API needs to pass us some additional things. And so it's going to be hard to make Hibernate ship actual Java 9 compliant modules because we depend on these, and there are no modules for these specifications available yet. But as long as you don't want to have Hibernate running as a module itself, everything is just working fine. And we have just 1 minute left for some questions. Yes, please.
It's a question about Hibernate Search. What will happen if you try to save to Elasticsearch, but Elasticsearch is down or not transferring?
Okay, so the question is about Hibernate Search and what happens if Elasticsearch is down while we're attempting to write to it. Now, that depends how you configure it. By default, we consider that the search engine can lag behind. So you could configure an error handle so that you know that an error happened and you can deal with it by invoking there is a manual indexing API so that you can repeat indexing of this. But there also is a configuration in which you can request that all the updates that need to go to the search engine actually are part of the transaction. In this case, we're using JMS, and so all the changes are actually committed transactionally in the database and in the JMS queue. And when the system goes up, it should be recovering from that. This is not a default because it has a performance penalty. And for most people, having stuff, let's say you have a web shop, that something isn't appearing in real time in your catalog is acceptable, and they will just rebuild the index nightly. There is a mass indexer, which is it's a job that will scan your whole database and rebuild the index from scratch. So some people just run this mass indexer nightly to compensate for issues like this one. Well, thank you very much.